Now in this video, we're going to talk about doing things at the end of the array. So let's look at what's involved in inserting last. Right? Again, we have two cases. If the list is empty, there's nothing in the list, so the node that we allocate and fill in will become the only node in the list. So what's required? What does this mean? We're allocating this node, filling in this value, setting this to null, and then we simply say, head points to the new node. And we're done. Okay. Now what if the tree has nodes in it? The tree, not the list, has nodes in it. Then we're trying to insert where? At the last position. So let's suppose this has 3 nodes and we want to insert out here. What's required? Well, it looks like we need to go and park ourselves at the last node. We need to locate where the last node is, and we need a finger to point at that last node. We also need to allocate a brand new node, put a value into it. So those are the two things we have to do. We'll talk later about how to locate the last node. But think in terms of, I've got 2 steps. One is find my position in the list, then I work from that position. Now it turns out to add after a node is very easy because all we do is take this link field, because we're doing it at the end of the list, the link field, the next field will always be null. We just replace this field by a pointer to where the newly allocated node is. So basically all we're doing is we're taking this and making it point to that. Alright? That's the easy part. Now let's talk about the code that's required. Here's where we need to think in terms of functions. If we're given a list, we need a function that will go through the list and hand us back a pointer that says, here's where the last node is. And once we have that, as we've seen, it's pretty simple to do the insertion from that point on. So let's turn our attention to locating positions in a list. So, what have we here? Okay, and I don't have that. So let's talk about how we would do this. How would we find the last node? Let's go back to our beginning. If we're looking for the last node and the list is empty, what's the pointer to the last node? It should be null. Is that clear? So null means there is no last node. What if there are nodes? We have to go through the same process that we use to walk through a list. We start here, we say this is P, boom. We keep moving. How do we know that we have a last node? Well, the last node looks like this. The next field of the node is null. That means it's the last node. So we want to modify our traversal algorithm. And let's just so what's our traversal? It typically says P is head. I'm just use H just to keep it short. We're going to say while P is not equal to null, we do our stuff. We traverse. Say P point next. This is really messy. It's like Dot Allen's writing. Right. And all this loop is doing is traversing. It's just traversing. But the way this is written, what will the last value of P be? As we walk through, we go all the way until it is null. So on the end of this algorithm, we'll always get a null. So what do we want to happen? We want to say, do not go in the loop if I'm already perched at the last node. What does that mean? It means the node that I'm pointing to, if its next field is not null, then this is not the last node. So this has to be changed to what? P point next is not equal to null. All right, that's what we need to have happen, okay? This will ensure that we will not go in this loop when we're at the last node. So when this loop terminates, the value of P tells you where the last node is. All right, so let's combine two things. To add something to the list as the last node, we must first locate the last node. And by locating it means we need to get a pointer to the last node. Secondly, we then need to allocate a new node, put values into it, and then set the next field of the last node to point to the brand new node. Is that clear? Good. Next, we're going to talk about deleting from the last node. And let's just do let's do a switch. Let's see if there's one more thing in here. Delete last. Okay. Okay, here's deleting the last. Okay. Again, if there's nothing there, no problem. If there's one element, one node in the list, then our job is easy. All we have to do is set head to null, set head to null, and delete this node. Delete the first node. What order do we do this in? We do this first, and we do this second. All right. What do we mean by that? What is this? This says delete. What node? The node that head points to. Mouse is cutting up, okay? And the second step is just setting head to null. That's pretty straightforward. Now, what if we have other nodes in the list? What becomes the issue? Well, we saw in the last example that we have the ability to locate the last node. Now, can I delete this node by saying just delete this guy right here and we'll be done? No, because if we do, we will have the next to the last node pointing to something that doesn't exist anymore. Is that clear? So it sounds like we need another one of these little functions that says, tell me where the next to the last node is. Does that make sense to you? Because we need both of these to do the delete. Because if I have the last one and the next to last one, I know that all I've got to do is delete this one, and I've got to set the next field to in the next to the last to null, and then we're done. All right. So if I delete the last node, then the next to the last node must say I am the last node. So you need two pointers to delete at the end of the list. Now, what we will talk about maybe in class is how do you write this function find next to last. And we will see that it's not as hard as you think. Okay, with that, we're going to shut this down.